Hi, this is Mr. Mack. The concept today we're going to talk about is linear programming. Now, linear programming is a term that we use to describe a decision-making process that we might want to do in mathematics. A lot of times you have a situation where there are two or more quantities actually, that interact in complicated ways, and you want to make a decision that optimizes the situation. Optimize is a word that means to make best. It might be either the most or the least or something like that. Now, these two quantities ordinarily are under what we call constraints. Now, constraints is a word that talks about requirements and restrictions. In other words, sometimes there are things that you have to do with these quantities, and sometimes there are limitations to what can be done with these quantities. Both of these would be considered constraints, and many times what happens is the constraints translate into linear inequalities. Now, in the last section, we spent time learning how to find the solution set to a system of linear inequalities, and ordinarily that was a bounded region, region bounded by a polygon, or it could have been a region in the plane that had an unbounded spot in a certain direction. When we are doing linear programming and we translate the constraints into linear inequalities, the solution to the system of linear inequalities is called the feasible region, because all the points inside the graph of the solution of the system of linear inequalities are points that represent feasible choices that we could make in our situation. Now, not all of them are going to be the best, of course, but they're all possible to make. Now, in linear programming, what we try to do is we try to optimize the choices, and there's a couple of things that we know are true about feasible regions. Number one, for any objective, and an objective is something that you want to accomplish, for any objective, the optimal solution if it exists will be one of the corner points of the feasibility region. Now, this has been referred to as the fundamental theorem of linear programming. For any objective, the optimal solution, if it exists, will be one of the corner points, of the feasibility region. So what we do when we're trying to solve a linear programming problem is we first of all define, number one, we define the variables. It is important in these problems to write down what you define the variables to be, and the variables need to be the things that you're going to be making decisions about. How much of this, how many of that, or whatever. Define the variables, write it down so you don't forget. And then, given the constraints, we create linear inequalities containing those variables that are representative of the constraints to the variables. We then find the solution to the region, or to the system of linear inequalities, and that is the feasibility region. We then find the vertex points of the corners of the feasibility region, and we'll put those values in our objective and see which one of those makes it most and which one of them makes it least. Now let's spend just a moment looking at this if it exists. How could an optimal solution not exist? Well, it's really pretty easy. If you have a feasibility region, and I'm just going to graph something here. Let's say you have a feasibility region like this, and the area of the solution set is this part right here, and it keeps on going in that particular direction. Now what's going to happen is points along these lines as you move this way, points along these edges as you move this way, will make the objective go more and more in one direction or the other. In other words, it'll make it bigger and bigger, or it'll make it smaller and smaller. Now when that occurs, whoa, you scared me. When that occurs, there is not going to be an optimal solution in that particular direction. In other words, if these points as they go along this particular line here make the objective larger and larger, then there will be no bound to the maximum. But there will be a bound to the minimum, and it'll be at one of these three corner points here. Or if as these points go this direction, the objective gets smaller and smaller, then what's going to happen is that the maximum will be at one of these 3 points. So if your feasibility region is unbounded, most likely what's going to happen is you'll have an optimal solution in one direction, either maximum or minimum, but not in the other direction. So when you have an unbounded feasibility region, you need to try a couple of points along the line towards which the feasibility region is unbounded, and whatever direction the objective is going in that particular direction, there will not be an optimal solution in that direction. It'll just keep on going farther and farther and farther. Now, it is important that you take a look at the solution videos to this particular section, because there are a lot of solution videos, and each one of them is a linear programming problem. There are a couple that are word problems, and there are a lot that are just kind of algebraic. They don't have the word part of it, the context along with it. But the only way to understand this is to actually go through some of those problems, and you really do need to look at those solutions and follow along as they are being done. Good luck on that, and that takes care of the concept video for linear programming. We're done.